Hello and welcome everyone. I am delighted to have this opportunity to speak with you today about the exciting topic of Aptos Move VM. It is my pleasure to share with you some insights about this innovative technology and how it can revolutionize the way we think about virtualization. So, without further ado, let's dive into the world of Aptos Move VM and explore its remarkable capabilities. My name is Samar and I am thrilled to be here today to speak with you about Aptos Move VM. As a full-stack developer, I have always been passionate about exploring new technologies that can enhance the performance and efficiency of software applications. Today, I am excited to share my insights on Aptos Move VM, a cutting-edge technology that can streamline the virtualization process and provide developers with an unparalleled level of flexibility and control. During this presentation, I will provide an overview of Aptos Move VM and discuss its features and benefits. I will also share some use cases and examples that demonstrate how this technology can be leveraged to build robust and scalable software applications. So, let's dive into the world of Aptos Move VM and explore how it can transform the way we think about virtualization. Thank you for joining me today. Before we start, I'd like to take a quick brief about Aptos. Aptos is a blockchain-based technology company that aims to revolutionize the way businesses operate by providing a decentralized, secure, and efficient platform for transactions. The Aptos blockchain is designed to handle a high volume of transactions, making it ideal for applications such as digital asset management, supply chain tracking, and peer-to-peer transactions. At the heart of the Aptos blockchain is the Move language, which was created specifically for the platform. Move is a high-level programming language that is designed to be safe, efficient, and scalable. It is used to write smart contracts and other blockchain applications that run on the Aptos blockchain. In today's presentation, we will delve deeper into the Move language and the Move VM, which is the virtual machine that executes Move code. We will explore the core security mechanisms of the Move language, how Move bytecode is executed in the Move VM, and the security design of the Move VM. We will also compare the Move VM to other virtual machines such as WASM and EVM, and discuss the advantages and disadvantages of each. Before we get started, I'd like to remind you that if you have any questions or comments during the presentation, please feel free to ask or leave them in the chat, and I will be happy to address them. So, let's dive in and explore the fascinating world of Aptos technology and Move language. In today's presentation, we will delve deeper into the Move language and the Move VM, which is the virtual machine that executes Move code. We will explore the core security mechanisms of the Move language, how Move bytecode is executed in the Move VM, and the security design of the Move VM. We will also compare the Move VM to other virtual machines such as WASM and EVM, and discuss the advantages and disadvantages of each. Before we get started, I'd like to remind you that if you have any questions or comments during the presentation, please feel free to ask or leave them in the chat, and I will be happy to address them. So, let's dive in and explore the fascinating world of Aptos technology and Move language. Another important feature of Move is its efficiency. Move is designed to be resource efficient and scalable, which is essential for running blockchain applications that can handle a large number of transactions. Move's efficiency is achieved through a number of optimizations, including the elimination of unnecessary code and the use of a compact bytecode format. It is important for developers and businesses to understand the Move language and the Move VM. The Move language is the foundation for writing smart contracts and other blockchain applications on the Aptos blockchain. And the Move VM is the virtual machine that executes Move bytecode. Developers who are interested in building blockchain applications on the Aptos platform should be familiar with the Move language and how it works. Understanding the Move language can help developers to write more efficient and secure code, which can lead to better performance and fewer security vulnerabilities. For businesses, understanding the Move language and the Move VM is important for making informed decisions about which blockchain platform to use for their applications. By understanding the features and benefits of the Move language, businesses can determine whether the Aptos blockchain is the right choice for their needs. In summary, the Move language is a safe and efficient programming language that is designed for the Aptos blockchain. Understanding the Move language and the Move VM is important for developers and businesses who are interested in building blockchain applications on the Aptos platform. By understanding the Move language, developers can write better code, and businesses can make informed decisions about which blockchain platform to use. Here's an example of Move code. This code defines a simple smart contract that allows users to deposit and withdraw funds from a virtual vault. The deposit and withdraw functions update the balance of the sender's vault. The main function calls these functions to deposit 100 units and then withdraw 50 units. The vault module defines the vault resource struct, which is used to store the balance of each user's vault. The create function is used to create a new vault resource for each user. Note that this is just a simple example, and Move code can be much more complex depending on the requirements of the smart contract or application being developed. Let's dive deeper into the Move language and its core security mechanism. Move is designed with a strong focus on safety and security, which is essential for blockchain applications. The Move core security mechanism is a set of rules and restrictions that are enforced by the Move compiler and Move VM to ensure the safety and correctness of the code. The Move core security mechanism includes several features that set it apart from traditional programming languages. For example, Move uses a resource-based memory management system, which ensures that resources are used and released correctly. In traditional programming languages, memory leaks and other resource-related bugs are common sources of security vulnerabilities. Another key aspect of the Move core security mechanism is its use of formal verification techniques. Move programs can be verified using automated tools to ensure that they meet certain safety and correctness properties. This makes it possible to prove that a smart contract is free from certain types of vulnerabilities before it is deployed to the blockchain. Move also has a strict typing system that ensures that data is used and manipulated correctly. Move's type system is designed to prevent type-related errors that can cause security vulnerabilities in traditional programming languages. In addition to these features, Move also includes built-in support for several security-related features, such as authentication and access control. This makes it easier to write secure smart contracts and other blockchain applications. Compared to traditional programming languages, Move's focus on safety and security is a major advantage for blockchain applications. Traditional programming languages are not designed with the same level of security in mind, and they often lack the features and tools necessary to ensure the safety and correctness of code. In summary, the Move core security mechanism is a set of rules and restrictions that are designed to ensure the safety and correctness of code on the Aptos blockchain. Move's focus on safety and security, resource-based memory management, formal verification techniques, strict typing system, and built-in security features make it a powerful tool for building secure blockchain applications. Compared to traditional programming languages, Move's security focus is a major advantage for blockchain developers and businesses. Here's an example of Move code that demonstrates some of the security features mentioned. In this example, the transfer function is a simple smart contract that allows users to transfer funds between accounts. The function takes an amount and a recipient address as input. The move_from and move_to functions are used to move resources between accounts. These functions ensure that resources are used and released correctly, preventing common types of security vulnerabilities such as reentrancy attacks. The assert function is used to check that the sender has sufficient funds to make the transfer. This prevents the smart contract from executing if the sender does not have enough funds, which could otherwise lead to security vulnerabilities such as negative balances. The vault module defines the vault resource struct, which is used to store the balance of each user's vault. The create function is used to create a new vault resource for each user, and the get_balance function is used to retrieve the balance of a given account. Note that this is just a simple example, and Move code can be much more complex depending on the requirements of the smart contract or application being developed. Now let's explore Move bytecode, the low-level representation of Move programs that is executed by the Move virtual machine. Move bytecode is a binary format that is generated by the Move compiler from Move source code. It is a stack-based language, similar to other bytecode formats like Java bytecode and Ethereum Virtual Machine (EVM) bytecode. Each instruction in Move bytecode is represented by a single byte opcode, which is followed by 0 or more operands. The operands are pushed onto the operand stack and used as inputs for the instruction. The instruction then operates on the inputs and produces outputs, which are also pushed onto the operand stack. One of the key features of Move bytecode is its support for resources. Resources are represented as separate sections in the bytecode, and each resource has a unique type and a unique identifier. This allows the Move VM to manage resources more efficiently and enforce Move's resource semantics. Move bytecode also includes built-in support for type checking and verification. Before bytecode is executed, it is verified by the Move VM to ensure that it is well-formed and conforms to Move's type system. This helps to prevent runtime errors and security vulnerabilities that could be caused by type-related issues. Compared to other bytecode formats, Move bytecode is designed specifically for blockchain applications and is optimized for the unique requirements of the Aptos blockchain. It includes features like support for resources and formal verification that are not present in other bytecode formats. To execute Move bytecode, the bytecode is loaded into the Move virtual machine, which is responsible for interpreting the bytecode and executing the corresponding instructions. The Move VM is designed to be fast and efficient, with optimizations like just-in-time compilation and a high-performance garbage collector. In summary, Move bytecode is a binary representation of Move programs that is executed by the Move virtual machine. It is a stack-based language that supports resources, type checking, and formal verification. Compared to other bytecode formats, Move bytecode is optimized for blockchain applications and includes features that are specifically designed for the Aptos blockchain. The Move virtual machine is responsible for executing Move bytecode and is designed to be fast and efficient, with optimizations that make it well-suited for blockchain applications. Here's an example of Move bytecode for the transfer function we discussed earlier. Each line of this bytecode represents a single instruction, with the opcode listed on the left-hand side and the operands listed on the right-hand side. For example, the first line, 00000017, represents the length of the bytecode, which is 23 bytes in this case. The second line, 03, represents the get_sender instruction, which pushes the address of the sender onto the operand stack. The third line, 230000, represents the move_from a sender, vault instruction, which moves the sender's vault resource into memory. The fourth line, 03, again represents the get_sender instruction, which pushes the sender's address onto the operand stack. The fifth line, 230100, represents the move_to sender, vault instruction, which moves the updated vault resource back to the sender's account. The sixth line, 0000, pushes the transfer amount, i.e., 0, onto the operand stack. The seventh line, 25, represents the sub instruction, which subtracts the transfer amount from the sender's balance. The eighth line, 0001, pushes the recipient's address onto the operand stack. The ninth line, 230200, represents the move_to recipient, vault instruction, which moves the updated vault resource to the recipient's account. The 10th line, 0002, pushes a success flag onto the operand stack, i.e., 1 for success, 0 for failure. The final line, 45, represents the assert instruction, which checks that the success flag is equal to 1. If it is not, the transaction is reverted and any changes made to the blockchain are rolled back. I will be discussing the security design of Move VM. This virtual machine was developed specifically for the Libra blockchain, and is used to execute smart contracts on the network. Firstly, let's take a look at the overview of the security design of Move VM. The Move VM is designed with several layers of security that aim to protect the network against attacks. One of the main design goals of the Move VM was to prevent the loss of user funds due to vulnerabilities in smart contracts. This was achieved through a few key design features. The first security feature of Move VM is its unique type system. Move uses a resource-oriented type system that is designed to prevent common vulnerabilities such as reentrancy attacks, which occur when a smart contract is called repeatedly before the previous call has completed. This type system also ensures that resources, such as tokens or digital assets, are not created or destroyed without proper authorization. Another important feature of Move VM is its bytecode verifier. This component is responsible for ensuring that smart contracts are executed as intended, without any malicious or unintended behavior. The bytecode verifier checks the validity of the code before it is executed, preventing any potential issues that could lead to funds being lost. Furthermore, Move VM includes a secure execution environment. This means that smart contracts are executed in an isolated environment, separate from the rest of the network. This prevents malicious actors from interfering with the execution of the contract, and ensures that the contract operates as intended. Moving on, let's discuss how Move VM protects against common attacks. As previously mentioned, Move VM's unique type system and bytecode verifier provide several layers of protection against attacks. In addition to these features, Move VM also includes a strict access control system. This ensures that only authorized parties can access and modify the state of the smart contract. In terms of comparison to other VMs, Move VM has several advantages in terms of security. Compared to Ethereum's EVM, Move VM's type system is more secure and less prone to vulnerabilities. Additionally, Move VM's bytecode verifier is more robust, ensuring that smart contracts are executed as intended. In conclusion, the security design of Move VM provides a secure and reliable execution environment for smart contracts on the Libra blockchain. Through its unique type system, bytecode verifier, and secure execution environment, Move VM is able to prevent common attacks and ensure that user funds are protected. In comparison to other VMs, Move VM offers several advantages in terms of security. Here's an example of code written in Move programming language. This code is a Move script that defines three functions: mint_new_coin, transfer_coin, and get_sender_balance. These functions are designed to facilitate the transfer of a custom coin on the Libra blockchain. The mint_new_coin function creates a new instance of the custom coin, represented as a vector of bytes. The transfer_coin function transfers a specified amount of the coin from one account to another. The get_sender_balance function retrieves the current balance of the sender's account. This is just a simple example of the kind of code that can be written in Move. The language is designed to be safe and secure for smart contract development, and provides features like resource types and strict typing to prevent common vulnerabilities. Then, I will be discussing the advantages and disadvantages of different virtual machines, including Move VM, WASM, and EVM. Virtual machines are critical components of modern blockchain systems, and provide a secure and reliable execution environment for smart contracts. Firstly, let's take a look at an overview of different VMs. Move VM was developed specifically for the Libra blockchain and is used to execute smart contracts on the network. WebAssembly, WASM, is a portable binary format that is designed to run on the web, but can also be used for blockchain smart contract development. Ethereum Virtual Machine (EVM) is the virtual machine used by the Ethereum blockchain and is widely used for smart contract development. Now, let's compare the advantages and disadvantages of each VM. One of the key advantages of Move VM is its unique type system. Move's resource-oriented type system is designed to prevent common vulnerabilities such as reentrancy attacks. Move VM also includes a bytecode verifier that ensures that smart contracts are executed as intended, and a secure execution environment that isolates smart contracts from the rest of the network. WASM, on the other hand, is designed to be a portable and efficient binary format that can be used across different platforms. It provides a high level of security by enforcing strict sandboxing of untrusted code. However, WASM's security model is limited compared to MoveVM and EVM, as it doesn't have the same level of access control or resource management features. EVM is known for its wide adoption and support in the blockchain community. It is a Turing-complete virtual machine, meaning that it is capable of executing any arbitrary program. However, this flexibility comes with the downside of being prone to common vulnerabilities such as reentrancy attacks and integer overflow/underflow errors. In terms of use cases, MoveVM is specifically designed for the Libra blockchain and is best suited for applications that require high levels of security, such as financial services or digital asset management. WASM is a more general-purpose VM that can be used for a wide variety of applications, including web development and gaming, as well as blockchain smart contract development. EVM is best suited for applications that require a high degree of flexibility and functionality, such as decentralized exchanges and prediction markets. In conclusion, each virtual machine has its own unique advantages and disadvantages. MoveVM provides a high level of security and reliability. WASM is a portable and efficient binary format, and EVM is widely adopted and flexible. When choosing a virtual machine for blockchain smart contract development, it is important to consider the specific needs of the application and weigh the trade-offs between security, flexibility, and efficiency. Here is an example of a smart contract written in Solidity, which is the programming language used for smart contracts on the Ethereum blockchain. This is a simple example of a token contract. The contract creates a token with a total supply of 1 million and a symbol of MTK. The balance of mapping keeps track of the balance of each account, and the transfer function is used to transfer tokens from one account to another. When a transfer occurs, the function first checks that the sender has enough tokens to transfer. If they do, the tokens are subtracted from the sender's balance and added to the recipient's balance. Finally, an event is emitted to notify any interested parties of the transfer. This contract demonstrates some of the basic features of Solidity, such as state variables, mappings, and events. Solidity also supports more advanced features such as inheritance, interfaces, and libraries, which can be used to create complex smart contracts. It's worth noting that this contract is just a simple example and does not include all of the necessary security features for a production-level contract. Smart contract development requires careful attention to security and best practices to prevent vulnerabilities and protect user funds. Here's an example code snippet that compares the advantages and disadvantages of MoveVM, WASM, EVM, and other VMs. The code snippet provides a comparison of the advantages and disadvantages of several virtual machines, VMs, that are commonly used for executing smart contracts on blockchain platforms. First, the code snippet discusses the advantages of MoveVM. MoveVM is specifically designed for blockchain and smart contract execution, which makes it efficient and cost-effective. It also provides type safety and supports resource management, which helps to prevent common programming errors. However, MoveVM is not widely adopted and lacks community support, and there is limited documentation and tooling available for it. Next, the code snippet discusses the advantages of WebAssembly, WASM. WASM is portable and widely supported, making it a popular choice for blockchain platforms. It offers high performance and efficient execution and has a large community and ecosystem. However, WASM is not specifically designed for blockchain or smart contract execution, which means it lacks support for certain features such as resource management, and it can be vulnerable to certain security risks. The code snippet also discusses the advantages of Ethereum Virtual Machine (EVM), which is widely adopted and supported in the blockchain community. EVM offers a large ecosystem of tools and resources, supports a wide range of programming languages, and can be used for executing smart contracts on the Ethereum blockchain. However, EVM has some disadvantages, including inefficient execution and high gas costs, lack of type safety and resource management, and vulnerabilities to certain security risks. Finally, the code snippet notes that other VMs can be designed for specific use cases, and can offer unique features or optimizations. However, these VMs may have limited adoption and community support, as well as limited documentation and tooling. In conclusion, the choice of VM depends on the specific use case and requirements. MoveVM offers efficiency and safety for blockchain and smart contract execution. WASM offers portability and high performance, EVM offers wide adoption and language support, and other VMs can offer unique features or optimizations. Developers should carefully evaluate the advantages and disadvantages of each VM before choosing one for their project. Here's a script you can use for your presentation. Thank you for joining me today as we explored the exciting world of Aptos technology and the Move language. Before we wrap up, let's take a few minutes to recap what we've learned. Firstly, we learned that Aptos technology is a powerful blockchain solution that leverages Move language to provide secure and efficient smart contract execution. Move language is a statically typed language that offers unique features such as resource management and prevention of common programming errors. Here's a script you can use for your presentation. Thank you for joining me today as we explored the exciting world of Aptos technology and the Move language. Before we wrap up, let's take a few minutes to recap what we've learned. Firstly, we learned that Aptos technology is a powerful blockchain solution that leverages Move language to provide secure and efficient smart contract execution. Move language is a statically typed language that offers unique features such as resource management and prevention of common programming errors. In conclusion, understanding Aptos technology and the Move language is crucial for anyone looking to develop secure and efficient smart contracts on the blockchain. By leveraging the unique features of Move language and the Move VM, developers and businesses can create smart contracts that are optimized for performance, secure, and cost-effective. Thank you for joining me today, and I hope you found this presentation informative. As we come to the end of our presentation, I would like to take a moment to thank everyone for attending today. I hope that you found this presentation informative and gained a deeper understanding of Aptos technology and the Move language. Remember that understanding the Move VM is critical for anyone looking to develop smart contracts on the blockchain. With its efficiency, low gas costs, and support for resource management, the Move VM offers a unique set of benefits that can help developers and businesses create secure and optimized smart contracts. I encourage you to explore Aptos technology and the Move language further and discover all the exciting possibilities that they offer. Thank you again for joining me today, and I look forward to seeing you at our next event. Have a great day.